Okay, welcome to this video. Today I want to talk about multiplication and division. Now, for a lot of you, this is going to be a revision from last year, but I want to maybe put a different slant on it than you've seen before. So first I'd like to talk about a bit of theory. So theory of dimensions. So this isn't going to get too crazy, but it will build on a platform that I will be referring to throughout the year, and I think will create a better conceptual understanding of multiplication for you that we can move on to further on down the track. So let's talk about dimensions. Zero dimensions, what I want you to think about is just a point. We have a point A here, we have a point B here, we have a point C. Okay, the point about this, sorry for the pun, about this zero dimensions is that if you get onto this point here, you can't move anywhere. You're stuck on that point. There's no dimension there for you to be able to move. Okay, now obviously as we go up from zero dimensions, we come up into one dimension. So one dimension is when we see this thing, so we've got a point and we get this point here and we get some other point, and then we join those points together, and you might have seen these things before. We call them a number line. Okay, so the number line is probably the best idea of a one-dimensional plane, or a single dimension line that you've seen before. So essentially when we've got this one dimension here, we've got 0, 1, 2, 3, 4, 5, -1, -2, 3, 4, -5, etc. Okay, so it keeps going, and we've probably referred to this in the past as the x line. Okay, now this will make a bit more sense later. So all the way to positive x, all the way down to negative x. And what we can do once we've got this single dimension here is we're not just stuck. If we were here on 2, we could add 3 and get to 5. Or we could subtract 4 and wind up at -2. Okay, so with one dimension we're not stuck. We can move along this line as we please. Okay, so then that moves us along to one dimension, two dimensions. So when we move into two dimensions, we have across here an x-axis. But if I multiply this dimension by another dimension, we end up with this thing like this, and you might have seen it before. It's the xy plane. Okay, and so what happens is if we got 1, 2, 3, 4, 5, and 1, 2, 3, 4. If we move 4 down this end and we multiply it by, move 5 down this way and we multiply it by 4 going up this way, we end up with this thing called an array. Okay, so you multiply numbers together, you end up with a new thing, a block. You don't just end up moving along this line, you end up creating this array, an area of space now. Okay, and so that array will be 5 times 4, 20 units worth of space. Okay, so that's how I want you to think about this multiplication. Multiplication is getting this 5 here and multiplying it by the 4, so you create an area, an array. Okay, so that's what's going on when you do multiplication. Right, let's have a look at how to do some multiplication then. Right, so we say the product of. So if we have the product of 4 and 6 is the same thing as 4 times 6. Okay, so if we say the product of 4 and 6, it's the same as doing 4 multiplied by 6. Okay, which, if you know your times tables, which you should, is 24. Right, difficult multiplication though can be computed with an algorithm. So an algorithm, we looked at them in the last video, but an algorithm simply means a series of steps that completes with a solution. Okay, so computer programs are made up of lots of algorithms. Algorithms is a series of steps that you do. There's a shoelace algorithm. You probably used it this morning. Okay, so for instance, we do this difficult multiplication. Now, when you are doing these multiplications, you line them up with the last number in this right-hand column. Remember that it doesn't necessarily have to be units and tens and hundreds and things, especially when we move into decimal multiplication. So when we carry this one out, just in case you've forgotten how to do it, 4 times 7 is 28, 2 times 1 is 2, plus 2 is 4. Hang on, what am I doing? 4 times 1 is 4, plus 2 is 6, 4 times 4 is 16. Right, now that we're moving on to this one here, which is the tens column, next one up, we have to multiply the whole answer here by 10. So that's why the 0 goes there. So 2 times 7 is 14, 2 times 1 is 2, plus 1 is 3, 2 times 4 is 8, and 8 plus 0 is 8, 10, 10, 10, 10,008. Okay? Right. Division. How many of number A's fit into this number B? So for instance, we might want to say how many of this number here, how many 4s fit into 25? So 25, how many 4s fit into 25? 6 fit into it with 1 left over. Now this whole 6 remainder 1, really, I don't want to see any more of that, okay? Because more so you'll be actually working out the decimal equivalent of these 6 remainders, okay? Right. Difficult division can be calculated with an algorithm. So in some cases you might be able to quickly do it if it's related to your times tables, but otherwise you'll want to use an algorithm. So probably the short division algorithm is what you've seen. So if I have this, 241 divided by 5 equals what? You set that up like this. So you draw your little division sum line here, and so the 5 goes here, and what you want to divide into goes here. Okay, right. So we ask ourselves, 5 into 2, none. How many 5s go into 24? Well, it turns out that there are 4 of them with 4 left over. How many 5s go into 41? There are 8 of them with 1 left over. How many 5s go into 10? 2. 48.2. How exciting. So that you'll have a bit of practice at that one in class just to make sure that you remember your division algorithms, because your first couple of exams and that kind of stuff won't be using calculators. We'll just be testing that you are able to carry out these algorithms on the spot. Right. Now the commutative and associative laws that you might have remembered from the last video, they do apply to multiplication. So for instance, 6 times 4 is equal to 24, which is the same as 4 times 6. Okay, so that's your commutative law. You can shift them around. The associative law also applies. So 6 times 2 times 2 is the same as 6 times 2 times 2. So 2 times 2 is 4. 6 times 4 is 24. It's the same as 6 times 2 is 12. Times 2 is 24. How surprising. So both that commutative and associative law work for multiplication, not division though. Okay, so only use it with multiplication, don't use it in division. Okay, So I hope you enjoyed that video. Again, it was very quick, just quickly smashing through this stuff because a lot of it is what you've seen before. It's just here, so just in case you forget how to do those algorithms, you have it here just to see a quick little example of it. So make sure you come to class with any questions if you can't quite remember how to carry those algorithms out. Okay, thank you.